Howdy folks, Dave here at Thunder Mesa Studio, where this week I want to bring you up to date on what's been happening with the On30 San Lorenzo mini layout. I first introduced this new project in a video at the end of November, and if you happen to miss that one, of course you can check it out at the link. But in a nutshell, what I'm doing is taking the original structures and figures and scenery items from Verne Niner's San Lorenzo diorama and incorporating them into a 2x4 foot mini layout. Sadly, we lost Verne a few years back, and I'm hoping this little mini layout will pay homage to him and his wonderful On30 Estrella Sonora Grande layout. So what I hope to accomplish this time out is to get all of the track laid and everything wired up so we can actually get some trains running on this thing. So without any further ado, let's get started. I've gone ahead and removed all of the structures and everything else that was on here temporarily because the first order of business today is going to be running some wiring underneath the layout deck for the DCC system. And the easiest way to do that is to take this whole thing and flip it upside down. I like to use a 14 gauge wire for this. Some people like it a little heavier, some might like a little lighter. I like 14 gauge because it's still flexible enough to bend easily around corners and things like that. You want a pretty heavy duty, pretty robust wire for DCC systems because they carry more current than good old fashioned DC. And the reason we want wiring all the way around under the main line is so that we can drop feeder wires down from each individual section of track. I'm going to be using meter long flex track sections joined by nickel silver rail joiners, but you don't want to count on those rail joiners to carry the current from one section of track to the next. So that's why we do a DCC bus. It just makes for much more reliable operations in the long run. Those rail joiners can fail. You could have a bad solder joint. Many reasons why you don't want to depend on those exclusively for electrical contact. So it's just a good idea, good practice, even on a small layout like this, to run a DCC wiring bus. And I'm going to show you exactly how we do that. So I'm going to thread the wires through these 1x3 cross beams. And the wiring doesn't have to be directly, perfectly underneath the track. But if you can get it in the neighborhood, that's pretty good. Now I could get away with just putting one hole and threading both wires through there, but I'm doing two holes because I want a little bit of separation between the inside wire and the outside wire, just to keep them nicely organized. So this hole will be for the outside rail, the outside wire. This one will be for the inside rail, the inside wire. So we'll go red and this through this hole and black through that hole. It'll just keep things nice and organized. All right, let's see. This is the front. Yeah, so I decided the power is going to come in from this side. So we'll start over here. Thread this through the holes. Okay. Now over here, where the wires are going to run underneath where the bridge is going to be, there's going to be a little arroyo here. I'm just going to use my staple gun and tack the wires like that. I'll do the same thing with the black wire. Taking great care, of course, not to put the staple through the insulation, but on one side and the other. And I'll go ahead and tack them down at this end also. Okay. I haven't decided yet exactly where the controls are going to be. So I'm going to give myself plenty of slack here. And then just run the wires out through this hole. temporarily. Now you don't have to close this circuit, you know, by wiring this loop together, but I'm going to go ahead and do it anyway because it makes for a neater job. Take a little bit of insulation off here, matching up the 14 on my strippers with the 14 gauge wire. Peel this insulation off a little bit, about a half an inch of it. Take a little bit off the end of this. I'll splice these together. Using some 6040 rosin core lead solder here. Now we'll just wrap those up with some electrical tape. And that's a good warm-up for all of the soldering jobs that are left to do on this. There's going to be quite a few. And there is your DCC wiring bus. Now I can turn the whole thing over and start laying some track. And a comment on the previous video, somebody said they actually cringed when I covered up my track center lines with this cork, because how then would I know where the track is going to go? On a small layout like this, it's really not that big of a deal, and I'll show you exactly why. Now on a small layout like this, I almost always want to start by laying the track on the curves, because that pretty much determines the geometry for everything else. Now I'm using Micro Engineering Flex Track, Code 83 Flex Track, and this layout is designed with two 10-inch radius curves. And I've drawn out the center line of a 10-inch radius curve on this, this scrap piece of masonite. And one of the things I really like about this Micro Engineering Flex Track is that it will hold just about any shape you flex it to, which cannot be said of all brands of flex track. So I'm going to use this as a template and just bend this track to that 10-inch radius. There we go. And you can see here that bending that sharp curve has smushed two of these ties right up next to each other. That doesn't look very realistic, so the first thing I want to do is remove one of these ties before I go to lay the track. Cut through the webbing. There we go. That gives that rail a little bit of breathing room. And then that is going to go right there. Now I do have some marks on the roadbed here. I've measured in 2 inches from the edge in a few places and put a little mark to show me where the center line should be. But I'm just going to let the track kind of naturally find its own center line and just use those, as a general guide. One advantage of having such sharp curves on this is that I can get the whole thing with one 3-foot long piece of flex track. I don't have to solder two pieces together on a curve, which is always challenging and can lead to some weak joints if you don't do it exactly right. I honestly don't remember how Verne laid his track on the Estrella Sonora Grande. I think he used glue. I think he glued it down, but I'm going to use my preferred method, which is rail spikes right through the ties and right where the rail spikes would go if I was hand laying the track. These Micro Engineering ties are kind of a hard plastic, so you have to drill a little pilot hole. I've got a size 65 bit in my pin vise. Drill a little pilot hole and then just use my Xuron spiking tool to to drive in some micro engineering small rail spikes right next to where the cast-in spikes are. And I do that about, every 1, 2, 3, 4, 5, 6th tie or so on a curve, less on a straight piece of track. Just enough to hold it down. Doesn't take much. So we drill a little hole. Just through the tie. You don't need to go down through the roadbed. Position the spike in the pliers like so. And we'll push that home. Once the track is painted and ballasted, you won't see those spikes at all. They'll just blend right in. Even though they're a little bigger, than the cast-in micro engineering spikes, which are scale, by the way. So these are about 3 or 4 times the size. And we do one on each side. Just like that. And on we go all the way around the curve. So I finished spiking the rail around this curve, and now I'm coming into a straight section here. And usually I don't solder the rail joints on straight connections, and that's to allow for expansion and contraction of the rail seasonally, during changes of temperature, because this nickel silver rail will expand and contract quite a bit. But in this particular case, I am going to solder this connection right here, because I need to put a little bend, a little twist in this short piece of flex track. I've cut a piece about 6 inches long, and I need to flex it a little bit to mate up with the turnout and bring this back into alignment. Originally, when I drew this, straight parallel to the edge of the layout, but that's kind of boring to look at, actually. So I've built in a little bit of a wonky curve here, and that's just to make it more interesting. I'll let my soldering iron get good and hot, and now I'm going to put a little bit of no clean flux on this joint. I've also made sure that these rails and these rail connectors are very clean. I'm going to use the same 6040 rosin core solder here. Make sure that's lined up. That's plenty hot. Yep. Heat the joint and put a dab of solder. You can use the tip of the soldering iron to spread that out, just like that. Now the inside rail is always a little bit trickier. Let that cool for just a second. All right, now I can flex this piece around, put a little bend in it, so it'll align where the turnout's going to be without that rail pulling out of the rail joiner. Now I can go ahead and spike this piece down. By the way, when I push these spikes in, they're going all the way down through the tie, through the cork, and just the tip is going into that plywood. So you have a nice strong hold there. Now I want to just trim off just a little bit of that rail. I'll remove this tie. That out. Now on this joint, going into the turnout, I won't solder this one, and that's to allow for that expansion and contraction that I was just talking about. But before I permanently affix this turnout in place, I need to do one slight modification to it. This is a DCC ready micro engineering turnout. And what that means is that the frog is isolated. You see there's gaps there and gaps right there. So this is dead. There's no power coming through the rails to this frog. And that prevents a short on DCC systems. It also means that short wheelbase locomotives like Porters and things will stall on turnouts like this. So what I need to do is power this frog somehow. And the easiest way to do that is what I'm going to show you. And while I have the soldering iron nice and hot, I'm going to connect a wire. There's a little nub right there. You see that? That's so you can solder a wire in there and power that frog. And when we hook everything up a little bit later on, I'll show you exactly how that works. Right now, just want to tin this wire. This is some 28 gauge wire that I like to use for track hookups. Just adding a little bit of solder to the end of that. Some turnouts you get will already have a little piece of wire soldered on to this. This one does not. So got to do it the old-fashioned way. There we go. Now, connect the two together. Shouldn't take more than a touch. Okay, got a nice strong connection. Now I need to mark exactly where that is so I can drill a hole. That's better. Yeah. All right. Now we can spike the turnout down. On turnouts like this, I like to put a couple of spikes down at the point end, a couple, up here by the frog, whoops, and then a couple more at the diverging end. Now here where the track is coming out of the turnout, I'm not going to solder these rail joints. Once again, that's to allow for that expansion and contraction of the rails seasonally. But I have another joint up here that I am going to solder. And just real quickly, I'm not gapping the rails here where they come out of the turnout, and that's because this is a dead frog turnout. At least it'll be dead until I route power to it. And on the Pico turnouts, Pico On30 turnouts that I've used in other places on the Thunder Mason layout, stuff like that, you do need to gap at this end, anywhere the power is coming from the diverging end of the turnout to prevent a short circuit. But since this is a dead frog or will be a power routing frog, I don't need to worry about that. Now I can bring this around to the proper radius and spike it down. While I'm still over here working on this side of the layout, go ahead and put the spur track in also. Okay, now I can just flip the whole thing around and finish up the track on the other side. Now, since there's going to be a bridge over here on this side, it's pretty important that this is at an accurate and consistent 10-inch radius, because that's going to make the bridge a lot easier to build than if it's fluctuating all over the place. So to facilitate that, I've cut a little cardboard template here to a 10-inch radius. That's what this center line is. So I just need to make sure that the track is aligned on that center line. Got it propped up here with some foam while I spike down the other end right here. Now, if you watched the previous episode of this build, you might remember that originally there was a piece of roadbed here that would have been underneath the bridge temporarily, and would serve the same function as this piece of cardboard here. But I ended up cutting it out because it had gotten all chewed up while I was cutting out the roadbed. And this is just, this just goes to show that there's always more than one way to skin a cat. there's more than one way to do something. All right. That just leaves us with one final piece of flex track to lay to complete the loop. This is the final spike. Maybe I should paint it gold, huh? And with that, the final piece of track is laid. So, I think I'll come back tomorrow and we'll wire everything up and see how it runs. Now I'm soldering on some feeder wires to each one of those sections of track. A red wire for the outside rail and a black wire for the inside rail. And I'm using some 28 gauge solid core wire, which is my favorite for this kind of thing. But let me back up and I'll show you the whole process from the very beginning. So I've gone around with a Sharpie and marked a couple little black dots on either side of the track there, right up next to the rails. Where I want to drop feeders down. And like I said, I want to do that for every section of rail on the layout. And, it is a little bit overkill. It's kind of building in a redundancy. So if any of the other connections fail, there'll be a backup for it so you won't lose current to the rails. It's just a good practice. Now I've got a 1/16 of an inch drill bit in my drill, and I'm going to go through and drill down through the roadbed right up as close to the rail as I feel is safe without actually touching it. Now I want a couple of pieces of wire, about 9-10 inches long. I like to give myself plenty of slack to work with. Then I want to strip off about 3/8 to half an inch of the insulation just from one end of the wire. Feed that down through the hole. And here's the trick. When you get it down in here, when you've got, maybe 1.5 inches, 2 inches just left sticking out, you want to bend it back like this. Bend it back on itself. And take that exposed bit of wire and bend it over into an L shape. And then pull down from underneath. And the natural springy action of the wire is going to hold that in place for you right there in the rail webbing. And that should hold the wire in place long enough. Get some solder on there. And then you can just pull the wires down. All that wiring is hidden down below the layout deck. Okay, that's all the sections on this side. Now I'll flip the whole layout around and do the other side. We can flip the whole thing upside down again and solder the other ends of those feeder wires to the DCC bus that we installed back at the beginning. So there's nothing really tricky here. Don't have any reversing sections or anything, any weirdness like that. So I just need to come in and remove a little bit of the insulation here and there. And then connect the red wire to the red wire and the black wire to the black wire. I just like to twist it around like so. There are clever little connectors you can get for doing this. They're called suitcase connectors. In this case, you'd need some that would connect 14 gauge to 28 gauge wire. Couldn't find any of those available locally, so doing it here the old-fashioned way. A little solder, a little electrical tape, works just great. Okay, now I just need to do that on every one of these connections. About the only way you could possibly mess this up would be, by accidentally connecting the black to the red or the red to the black, causing a short circuit. That's pretty unlikely, even if you're colorblind. I'm just finishing up the final pair of connections here, and these are feeders coming off of the turnout. But I've also got an extra pair of feeder wires that I soldered on there, and those are going to help me power that frog on that turnout. Now, there are a few different ways that you can power the frog on a turnout like this one. You could use a switch machine like the ones available from Tortoise. You could use Tam Valley Depot frog juicers. Those work great. I use them on the Thunder Mesa layout and on the Goldfield and Calico. But for this project, I think we're going to go old school. I want to do it the same way that Verne Niner did it on the original Estrella and Sonora Grande, and that is with a single pole double throw switch like this one. Now you remember that green wire that we soldered to the underside of the turnout frog. Well, that's going to go to this center terminal on the switch, and then the other terminals get the wires coming from the DCC bus for the inside and outside rail, respectively, just like that. And this is going to allow us to switch the polarity of the frog depending on which way the turnout is thrown. I'm not sure exactly how I'm going to configure the controls on this. I haven't quite figured that out yet. So I'm going to temporarily affix this to the benchwork with some 3M sticky tape. And this will allow me to, test everything out, make sure everything's functioning the way I want it to before I install it permanently. To actuate the throw bar on the switch, I'm going to use a good old tried and true Caboose Industries ground throw. This is an HO scale one. I used these on the Thunder Mesa layout, and these were the same kind of ground throws that Verne used on the Estrella and Sonora Grande, so should work fine here. First thing I need to do is extend these ties coming out from the throw bar, so I'll have a place to mount that ground throw. And for that, I've cut a pair of O-scale 6x8s to length, and then when the track is painted and ballasted, that should blend right in. I want to make sure this ground throw is mounted about 1 1/8 inch minimum from this outside stock rail, so even the widest piece of equipment will be able to go through here and have clearance. Now I need to make a linkage go between the throw bar and the ground throw. I've got some music wire for that. I'm sorry I don't know the actual size of this music wire. It comes out of my scrap box. The actual size is not that important, as long as it's stiff enough and fits and works. So I'm going to put a bend in this end. Caboose ground throws usually come with little pegs on them. You probably have to cut those off and drill a hole for the other end of the wire, which is what I've done here. You want to make sure that the points are centered on the turnout. ground throw end, I like to bend this into a little U shape, so it'll hook in there. Again, making sure the points are centered and the handle on the ground throw is straight up and down. It goes down in there. Now the ground throw can be mounted. Make sure we're centered onto these extended ties with a couple of rail spikes or track nails. Now to power the layout, I'm going to be using an NCE Powercab. Those are super easy to set up. First thing I need to do is attach the DCC bus to this little plug, which goes into this faceplate, which will eventually be mounted wherever I want the controls to be. For now, I'm going to let it kind of float free. All right, and then that plugs in right there where it says track. Hard to miss. And the cable to the cab goes in right there. And then the other end, of course, plugs into the power cab itself. And then the power supply plugs in right there. Again, these are all marked, so it's pretty easy to follow. Okay, moment of truth. We're ready to plug this into power. And if there's a problem, we'll know right away. I should get a red indicator light there. Yep, that's good. Everything looks good here. Yeah, this has a built-in circuit breaker, so if there was any short circuits, if I'd wired anything up, backwards or wrong, this would shut down right away, and then I'd have to go troubleshoot the problem. But looks like we're in good shape to test everything out. Just cleaning the track here real quick with some odorless mineral spirits. Well, I've jumped ahead a little bit and started in on the base of the scenery for the arroyo, which is going to be over here. There's going to be a trestle across it. And that's because, I didn't want a big hole in the scenery here when I'm testing out equipment in case, God forbid, there's a derailment and it goes, plummeting down to the concrete floor. That would be a bad day. So I wanted to fill in this hole. And I've got a couple of blocks of foam just holding up the track here. This is some 1-inch thick polystyrene foam, which I'm going to be using for the scenery all over the layout. I've done a little bit of rock carving here, and don't worry, I'm going to go into great detail on how I build all of the scenery for this in a future installment. Right now, we've got Estrella Sonora Grande number 3 on the rails here. It's a 040 Porter, very short wheelbase locomotive. So if there's any problems, we'll find them. Oh, no problems going through the turnout. That's good. Bring her around to a stop here and we'll do some more testing with that turnout. So I want to take the toggle switch and put it in the center position. That kills any current to the frog. Just a good practice. Flip the points on the turnout for the diverging route, and then flip the switch over to power the frog with the correct polarity for the diverging route. switch things back to the main line. Off around the track we can go. One final little step I like to do is to take those ties that cut off laying the track, and I trim off the cast-in spikes, all that. Put a little glue on the bottom and slide them underneath those rail joints for a more finished look. And with that, I think it's safe to say that the track laying and track wiring for the San Lorenzo mini layout are done. Now I can move on to the scenery, and I hope you'll come back and join me for that future installment coming up real soon. Until then, you can also follow Thunder Mesa over on Instagram at thunder.mesa, and I hope you'll check out the resources available on the Thunder Mesa Studio website at thundermesa.studio. I want to thank you all for watching and following along throughout the year, and a very special thank you to all of our Patreon members who help to make these videos possible. Until next time, keep moving forward, my friends. Adios for now.